Good afternoon, all. Today we are going to study the tachometric surveying. Myself, Dr. Kashfina Kabdia Memon. I am in Technocrate Institute of Technology, Bhopal. Tachometric surveying. Tachometry is the branch of surveying in which the horizontal distance between the instrument station to the staff station and also the vertical distance of a point are determined. Here, chaining operation is completely eliminated. Tachometric is used when there is a steep ground, broken ground, or stretches of water. In rough country, both horizontal and vertical measurements are tedious and chaining is inaccurate, so this tachometric survey is preferred. This method is also used to find out the contours. The purposes of tachometry are to prepare contour map used in hydrographic survey, location survey for road, railway, reservoir, then checking of the distances which measured with the help of a tape, and to measure the horizontal distance at which the distance measured by the tape or chain is difficult. The principle of tachometry is based on the property of isosceles triangle. In isosceles triangle, the ratio of perpendicular from the vertex on their basis is constant. Here PQR, PQ dash R dash and PQ double dash are isosceles triangles whose bases are QR, Q dash R dash and Q double dash R double dash. At point P, PO, PO dash and PO double dash are the perpendicular to their respective bases. So this ratio is constant and this ratio is known as constant K. So in tachometric survey there are two things used. One is tachometer and another is the leveling staff. Tachometer is usually transit theodolite having a steady diaphragm. This diaphragm is equipped with two horizontal hairs called steady hair in addition to regular cross hairs. The additional hairs are equidistant from the central hair and the diaphragm commonly used in second slide. So these are the types of stedia hairs. A, in this there is a central hair and these two equidistant hairs are there. Another arrangement B or C or D or E or F can be the stedia diaphragms. Second one is the leveling staff or stedia rod. The stedia rod or staff used with tachometry may be usual type of leveling staff having least count of 0.005 meter. Stedia rod is usually in one piece, but for easy transport it may be folding. Width of staff is 5 cm to 15 cm and height is 3 to 5 meter. Generally 4 meter of leveling staff is used. It is graduated in meter or centimeter. The graduation must be simple and clear. So method of tachometry can be steady method or tangential method. Steady method can be of two types. One is fixed hair method or another is the movable hair method. Steady method. In this steady method, the tachometry is set up at station B and staff is held at another station Q. So this is the ray against upper hair, this is the ray against central hair and this is the ray against lower layer. So height between the upper and lower layer ray is known as S. So here the vertical angle is measured and this steady intercept is measured and capital D is determined with the help of formula. The leveling staff or steady rod with tachometry may be usual type of leveling staff having least count of 0.005 meter. Steady rod is usually in one piece. The staff intercept is S between the upper steady hair and lower steady hair is measured. The vertical angle is also measured. The horizontal distance d between P and Q and difference of elevation of P and Q is calculated from staff intercept and vertical angle is theta by using the formula. Fixed hair method. The upper and lower steady hair is fixed. The distance between the upper steady hair and lower steady hair is called steady interval is fixed. The value of staff interval S varies with the distance and generally steady method means fixed hair method. Movable hair method means steady hair is not fixed. Steady hair can be moved or adjusted by micrometer screws and in this method the staff intercept is fixed. The steady interval measured corresponding to staff intercept. So there are some of the differences between fixed hair method and movable hair method. In fixed hair method, the steady interval is fixed. In movable hair method, steady interval is not fixed. Here staff intercept is not fixed. Here staff intercept is fixed. Fixed air method is most commonly used to take reading speedily. But this method is not generally used because inconvenient to measure the steady interval accurately. Then here tacheometric and staff are used. Here substance, theodolite and staffs are used. Tangential method is the third method. In this method, the diaphragm of tachometer is not provided with a steady hair. Readings are taken by central horizontal hair. Staff with two targets at a fixed distance is used for taking readings. The vertical angle theta 1 and theta 2 are measured, and the vertical angle and fixed distance are used to determine the horizontal distance d. There is some of the differences between steady hair method and tangential method also. In steady hair method, the diaphragm of tachometer is provided with three steady hairs. Here, diaphragm of the tachometer is not provided with steady hairs. Looking through the telescope, the three steady readings are taken. Here, the readings are taken by single horizontal hair adjust upper and lower target respectively. Here, one vertical angle is observed. Here, two vertical angles are observed. In this method, the most common used in practice. This method is not commonly used in practice. So, in fixed hair method, there are three cases. First case when the line of sight is horizontal and staff is held vertical. Second case when the line of sight is inclined and staff is held vertical. In this, we can measure either angle of elevation, which will be plus theta, and considering angle of depression, which will be minus theta. When the line of sight is horizontal and staff is held vertical, this is the most common case. So here we can derive the horizontal distance formula. So these are some of the properties of our this lens system. Here by using this type of derivation we can determine the distance d is equal to f upon I into s plus f plus d. So this is known as f upon I, this ratio is known as k. This is known as multiplying constant, and f plus d is known as the additive constant. So d is equal to ks plus c. This is the formula for our tachometric survey. Vertical distance when line of sight is horizontal, the vertical distance will be 0. Second case, when the line of sight is inclined and staff is held vertical. So by using this type of measurements, we can derive the vertical distance formula, that is v is equal to L sin theta, that is k sin theta plus c sin theta. Now let us solve some numericals based on the tachometric survey. So in this we will use horizontal distance formula, d is equal to ks plus c, where d is the horizontal distance, s is the staff intercept, k is the multiplying constant, and c is the additive constant, already derived in the previous slides. So in this there are two readings are given. One is 45 meter distance, steady readings are this. 0.885, lower reading is 0.885, middle is 1.110, and higher reading upper reading is 1.335. Second horizontal distance observed is 60 meter. Here the readings are 1.860, 2.160 and 2.460. So the difference between 1.335 and 0.885 will be known as S1, and 2.460 and 1.860 is known as S2, and this is D1, this is D2. So by using these two we can determine the constants K and C. So D1 is equal to Ks1 plus C, D2 is equal to Ks2 plus C. So by applying these equations, we can write down two equations, and putting the value of S1 and D1 and S2 and D2 in this, we observed K is equal to 100 and C is equal to 0. This is the second example. In this, the steady reading with horizontal sight at the vertical staff at 50 meter away from the tachometer are 1.385 and 2.380. The focal length of object glass is 25 cm. The distance between the object glass and Tronian axis of tachometer was 15 cm. Calculate the steady interval. So in this, k is equal to d is equal to ks plus c. D is equal to f upon I into s plus f plus d, where d is given as 50 meter, s is equal to 2.380 minus 1.385, 0.995, f is equal to 25 centimeters, so we will convert it into meter, that is 0.25 meter. D is 15 centimeters, so means 0.15 meter. So in this equation, we will put all the values. 50 is equal to 0.25 this. By using this, we can determine the steady interval as 5 mm. Thanks.